Hello, everyone. Let's begin with a simple thought. Have you ever wondered how the devices we use every day, like our smartphones or the electricity powering our homes, actually work? At the heart of all this is physics, the science that drives every technological breakthrough. In fact, much of what we take for granted today, like energy conversion and communication technologies, all come from principles of physics. We'll start by looking at how physics influences different technologies, such as how solar and tidal energy are harnessed. Did you know that these energy sources are powered by nuclear fusion processes happening in the sun? That's right. And understanding these processes has led to innovations like solar panels and tidal turbines that we use today. Now, let's dive deeper into something we all use daily: communication. Have you ever listened to the radio or watched TV? Well, you've experienced the magic of electromagnetic waves at work. Electromagnetic waves, which travel through space and carry energy, are behind almost all long-distance communication. For example, radio waves allow us to broadcast signals to radios, while TV signals reach our homes to display our favorite shows. And, of course, wireless communication like Wi-Fi and mobile phones. All of these rely on electromagnetic wave propagation. Isn't that fascinating? Even X-ray machines, which are used to look inside the human body, work based on this principle. They send electromagnetic waves through our body to reveal structures like bones and organs, helping doctors diagnose conditions more accurately. Next up, let's talk about lasers. Lasers are incredible devices, and their applications are everywhere. Ever thought about how your barcode scanner at the supermarket works or how surgeons perform delicate operations? Lasers are based on the idea of population inversion, where atoms are energized to produce a concentrated beam of light. This simple principle has revolutionized medicine, communications, and even entertainment. For example, lasers are used in eye surgery to correct vision, and in industry to cut materials with extreme precision. And don't forget about your DVD player, where lasers read the data encoded on the disc. Let's move on to something most of us use every day: computers and calculators. These devices are based on digital electronics, a fascinating field of physics. At their core, computers work by processing binary code, a series of zeros and ones. But how does that relate to physics? Well, it's all about how electrical signals are manipulated to represent information. And calculators? They use the same principles to perform quick calculations. You may be familiar with how fast computers solve complex problems, but did you know this power comes from the tiny electronic circuits that work based on principles of electricity and magnetism? Now, let's look at telecommunication technologies like phones, telegraphs, and even fax machines. All these devices rely on physics, particularly electromagnetism. Take telephones for example. When you speak into a phone, your voice is converted into an electrical signal and sent through wires or the air as electromagnetic waves. And with fax machines, they scan and transmit images in a similar way. These technologies have shrunk the world and connected us all. Thanks to physics, the development of fiber optic communication now lets us transmit information at incredible speeds. With the push of a button, you can be chatting with someone halfway across the world. Finally, let's talk about the future: energy exploration. We are all familiar with the traditional sources of energy like coal, but physics is pushing the boundaries and helping us explore new, sustainable energy sources. Solar power, tidal energy, and even nuclear fusion are all based on deep scientific understanding of physics. Did you know that nuclear fusion, the process that powers the sun, could one day provide us with nearly unlimited energy? Scientists are working hard to harness this energy here on Earth, which could revolutionize how we power everything, from homes to entire cities. The possibilities are exciting. So, to sum up, we've seen how physics is behind the technology that powers our world, from energy sources to communication systems, and even life-saving medical tools like lasers and X-ray machines. Physics is not just a subject we study in textbooks, it's something that shapes every part of our lives. I hope you now have a deeper understanding of how physics influences the world around us. From the devices in our pockets to the energy that powers our homes, physics is truly at the core of it all. See you in the next session where we'll dive into another exciting topic.